to get my board set up here. We are going to talk about adding vectors and subtracting vectors from one another. So if we have two vectors, what will that look like? Also, we're going to talk about if we take a vector, we multiply it by a number, what happens to it. Okay? So if you take a look at the top of your notes, if we have a vector v, okay? Vector v is the initial vector, okay? That's the starting vector. Say we do 2 times v. Well, that's basically doubling that vector. So we multiply it by 2, it becomes twice as long. I know that picture's not great, right? It could be better. But if we multiply it by a half, it becomes half as big. Okay? So kind of what you would think of happening. Multiply by 2, it gets bigger. Multiply by half, it becomes half. Now, one thing that's different is negative v. Okay? If we multiply it by a negative, it switches direction. So if you look here, this is going up. As soon as we multiply it by a negative, now it's going down. Okay, so it does 180 and it flips directions if you multiply by a negative. Say we have two vectors, v and w. If we add those together, we create v plus w. Okay, you can kind of see that dotted line that shows that that's the resultant vector. Okay, and then here our initial are v and w again, but now we're subtracting. It's going the other direction. Okay, you can see the resultant there. So we're going to actually do these with numbers. We're going to take vectors and we're going to actually multiply by scalars and things like that. Okay, so your first kind of formula is if you multiply a vector by a number. Okay, all that happens is you take its component form and you multiply both parts by that number. So say k was 2. Okay, and you had the vector negative 2, 3. All you would do is like distribution. You would multiply the negative 2 by 2 and the 3 by 2. Okay? So if I did that, what would I have here? What would be my first number? Negative 4, 6. Okay? So that's all you have to do with this scale. And we're going to practice that. The next thing is adding two vectors together. Okay? When that happens, you add their like parts. So whatever number comes first, you add those together. Whatever number comes second, you add those together. Okay, so if we were to do this with this example, what would come first? What would I add first? Yep, negative 2 plus 0, and then second would be 3 plus 1. So you'd have negative 2, 4 for your result. Okay, so just adding those like parts. The last one is subtraction. Okay, you just have to be really careful. It's exactly like addition. You're just subtracting instead of adding. Okay, and you do those like parts. So here I would do negative 2 minus 0, 3 minus 1. So you would get negative 2 comma 2. Does that make sense? Not too hard? Okay. Now, what we may do is you may have a subtraction of vectors, but one of them is multiplied by 2 or something. Okay, and we're going to look at that. It's not too hard. You just have to be really, really focused on what you're doing. Okay. Questions for me? All right. Do some practice here. So if we have 2 times vector c, well, vector c is given. Okay, vector c is negative 4, 5, so it would look like this. Okay, we're taking vector c, multiplying it by 2, so it's a lot like distribution. So we'd have 2 times negative 4, and then 2 times 5. Okay, your result, negative 8 and 10. That's your ending vector, negative 8, 10. Now, if we do a plus b, okay, we have to add the like parts. So if you look at the first part of a is negative 6, the first part of b is 1. So we have negative 6 plus 1. Same thing here. For the second part, you add those together. So you'd end up with negative 5, 9. Okay, go ahead and try 3 on your own. You're going to do C minus C. Give 3 a shot on your own. Now you should be doing this in order. Whichever one comes first, that's what you have to lead with. So since C comes first, you do the negative 4 first, minus 1. And then you'll do 5 minus 7. Okay, so order does matter. You have to make sure you do those in order. So you get negative 5, negative 2. Or do you have no? Okay, questions on number 3? We do okay on that? Is that a yes? All right, number 4. Now we're going to add in a scalar here, okay? Now, it's not that big of a deal. You just have to, I would advise you to just write it out. So we're going to start with A. The first number in A is negative 6. So we're going to do negative 6. Okay, and what comes next in our problem here is minus 3 times C. Well, the first number in C is negative 4. Do the process again, but with the second set of numbers. So we're going to do the second number of A, which is 2, minus 3 times the second number in C. Now, you can put those in your calculator if you want. You do not have to do them by hand. So if I do negative 6 plus 12, that's positive 6, 2 minus 15, negative 13. Okay, so you can do it in your head, your calculator, however you want to do that. Questions so far? Okay. Easy peasy? Yeah, it's not bad. Okay. All right, number 5. Now, we may have to multiply it by a half. Not a big deal, okay? You won't have anything crazy with fractions, like maybe you'll have like a 4. I don't even know if you'll have a 4. You might just have something like a half, okay? It won't get too insane. So, we're going to do 1/2 times A. Let me go ahead and write A up here. Actually, I'll just write them all. So, A. Okay, there we go, so we don't have to flip. All right, so 1/2 A. So 1/2 times negative 6, so that's the first part of A, minus the first part of B, which is 1. And then you do the second part. So 1/2 times the second number in A is 2, minus B, which is 7. And then you simplify. Again, you can do it in your calculator or in your head. Should end up with negative 4 and negative 6. Okay, I want you to give 6 a shot by yourself. By 6 on your own. believe that's what you should end up with. Check my answers. Make sure we're getting the same thing. Should end up with negative 2638. Issues, questions? Do you get the same thing? Yes? Okay, good. So that's really all there is to the scalars adding and subtracting. It's not too bad. Okay. Questions before we move on? Okay, the last thing we're going to do is unit vectors. Okay, unit vectors have this formula. I already have it up there for you. Okay, there's your formula. Well, I'm going to break it down here in a second. Okay, so with unit vectors, if we have a vector, say we have vector v, we can find another vector called u that's in the same direction as v using this formula. Okay, so say we're given v. Okay, say we're given, I don't know, I'm just going to make it up. Okay, we're given v. All we have to do is do 1 over, what is this? What's this part right here? The magnitude, okay? So you do 1 over the magnitude times your original vector. That will give you something called a unit vector that's in the same direction as your starting vector v. Okay? So really the process is finding the magnitude and then just multiplying it to the vector you already have. Okay? So we're going to look at just some examples here. Okay? So the first step is to find the magnitude of what you have. And we've been doing that a lot. We've been doing that since day 1 here. Okay? Here is your formula right over here. Okay? Square root of a squared plus b squared. So in this case, we'd have negative 5 squared plus 12 squared. Now, important, because when we've been finding the magnitude, we've just been writing the decimal. We don't want the decimal. If it's not a nice number, we want to leave it as a square root. Okay? I'm going to show. Let's just walk through this in the calculator together. So I want to show you what I mean. Okay, so if I do negative 5 squared plus, what was my other number? 12 squared? Okay, I get 169. Now, you have to kind of know your perfect squares. Does anybody know if 169 is a perfect square? It is. It's 13. Here's how we can check it. Okay? If you do second square root of your number, okay, if it comes out nice, it's a perfect square. If it doesn't, example, right, if it doesn't, then that means you have to do a different process. We'll get to that here in a couple questions. Okay? But for now, it's just 13. So we're going to use just that 13. Okay? If it was a square root, we'll talk about that in a second. But this one turned out nice. Okay? Step 2 is put it in that unit vector formula. Which is this one right here. Okay? You're going to put it right into that formula. So we have u equals 1 over 13. We found that 13 was our magnitude. And we're multiplying that by v. This right here, that v is your original vector. And again, this is just like distribution. Okay, it's that multiplication. So you do 1 over 13 times negative 5, which is negative 5 over 13. And 1 over 13 times 12, which is 12. Okay. Now, last step, can we break those fractions down? Can they be reduced? No. Okay, there's nothing we can do with those fractions, so we're done. That's our final answer. All right, let's do another one. So first step, what do? Find the magnitude of n. So if I put it in my calculator, I'm just going to go ahead and put in the square root, and if it doesn't work, then we'll go from there. Okay, we got a nice number. That won't always happen. If it doesn't, you got to go back and just get the square root. Okay, so we get 15 for our magnitude. We're going to put it into our formula. Okay, and then we distribute. Now from here, it's a good answer, but it's not the best answer. We need to reduce that fraction. Okay, here's how to do that if you're not good at reducing in your head. Okay, go into your calculator, type in 9 divided by 15, enter, math, enter, enter. It'll give you the reduced fraction. So put it in, press enter, math, enter, enter. It'll tell you 3/5. So 3/5 to start. We can do the same thing for 12 over 15. 12 divided by 15. Math, enter, enter. 4 over 5. That's your final answer. Okay. Not too bad. It's a little bit of a process. Okay. The hardest part about this process is just the reducing. We're going to add to that with radicals. Okay. So our next one's going to have a radical in it. Okay. Spoiler alert. So first step though, everything's the same. What do we do first? We find the magnitude. Okay, now I'm going to show you how we know that we're just going to have radicals here. Okay, if I put it in, okay, we get an ugly number. Here's what I would do from there. Take out the radical. Okay, so just do -4 squared plus -1 squared. Okay, you get 17. That lets us know that we're going to have the square root of 17. Okay, if we have the square root of 17, can I break that down? Before Thanksgiving break, that Tuesday, we did trig and we did breaking down radicals. So are there any of these perfect squares that go evenly into 17? No. Okay? If there was, we would need to reduce it. But there's not. So we're going to leave radical 17 alone. That's going to be our magnitude. So we're going to go ahead and plug it in. A different color here. To our formula. Okay, I have a bad news because we cannot have a radical in the denominator. Okay, here's what we do if we get a radical in the denominator. I could show you the whole process of something called rationalizing. I'm not going to do that. I'm just going to show you kind of the quick trick. Okay, so here's what happens. If you have a radical in the denominator, it turns into this. Okay, you put the radical in the numerator, keep the number downstairs. Yes? You see what I did there? Okay, took the radical, put it upstairs, but I kept the number. Okay. Now we can multiply. Okay. Some people are not really sure about multiplying with a radical, what that looks like. Here's what happens. When we do radical 17 over 17 times -4, the -4 goes to the numerator. But that -4 and that square root of 17 are not like terms. So you cannot combine them. You just kind of let them hang out right next to each other. Okay? And then your denominator stays the same, radical 17. So if we multiply it to the -1, you'd have -1 radical 17 over 17. Are you with me? Same thing here. Okay, first step, we're going to find the magnitude. Okay, ugly number, that's okay. We're going to go ahead and put it in by itself and see what our number under the radical is. $320. Okay, so we're going to have to break down this radical. All right, we need to look at our perfect squares and find the biggest perfect square that goes into 320. So here's how I would go about doing that. Okay, go into your calculator, 320 divided by 4. Okay, 80. Now that could work, 4 and 80, but is there a perfect square that goes into 80? Probably. 80 divided by 4 would probably be even, right? 20. So that's how we know that 4 and 80, number 4 is not the biggest. So let's do 320. We'll just try 16. 16 and 20. Okay, well, 16 is perfect square. Now look at 20. Is there a perfect square that goes into 20? Yes, 4 goes into 20. Not the biggest. So let's try again. 320, I don't know, maybe 36? Nope. Maybe 64? Yep, 64. Okay, now 64 and 5. Does 5 have a perfect square that goes into it? No. That's how we know we now have the biggest one. So our two numbers, we're going to break it down into square root of 64, square root of 5. Okay, what's the square root of 64? What's square root of 64? 8. Okay, so our magnitude is 8 square root of 5. All right, now we can finally put it into our formula. Right, 16. Issue? What's my issue? Huh? Yeah, radical is the denominator. So, from our trick, what should our numerator be? What should our numerator be? Over here, it switched from this to this. Okay, so our new numerator was the radical. Not just 5, radical 5. Yes? Okay. Why didn't I take the 8? The 8's not in a radical. Okay, the 8 is permanently downstairs. Okay, now, the 8's there, but what did I do here that I haven't done yet? Huh? Yeah, you have to leave the number in the denominator. So we took the radical, moved it upstairs, but we have to also put that 5 downstairs. So you're going to have to end up multiplying that 8 and that 5 together. Okay, so when we multiply the 8 and the 5, what do I get? 40. Okay, we're still working. This is a long one. Okay, so we still have our vector here. Now we can multiply, finally. So we end up with 16 radical 5 over 40 and negative 8 radical 5 over 40. Another bad news. We need to reduce. Okay, so if you look at 16 over 40 and negative 8 over 40, those need to be reduced. Okay, and you can do that in your calculator with the method that I showed you. So if I do 16 divided by 40, math, enter, enter, 2/5. And then the other one is negative 8 over 40, negative 1/5. Okay, so when I write this, this will be 2 radical 5 over, was it 2/5? Over 5. This one will be negative 1 radical 5 over 5. Okay, I changed my color of my marker, my fault. This is, it is. It's not bad. Like if you look at numbers 1 and 2 that we did on these, it's not bad. But when you get here, it's a lot. Okay. The last two. Okay. The last two, we will do those. We'll start with these on Monday. It's the same process, but you don't have component form. Okay. So on your quiz today, you did this, right? You found the component form. We just have to do that before we do the other process. Okay? What we'll do on Monday, we'll finish up 2 questions. We're going to get some practice under our belt on Monday, okay, because I know it's a lot. So we'll just keep practicing and going through this stuff on Monday.